So given that f of x equals 8x minus 5 over cx plus 6, for part A we have to find the value of c, also given that the line x equals 3 is a vertical asymptote to the graph. So basically the fact that it's an asymptote means that it'll never contact f of x. So we know over here, actually, they've given us a big hint that x cannot equal to negative 6 over c, because that's the part which makes the denominator 0, and therefore it makes f of x undefined. So let's just substitute 3 into this equation here that they've actually constructed for us. So 3 is equal to negative 6 over c. So easily we know that c is equal to negative 6 over 3, which is just negative 2. It's pretty simple. Now we can move on to part B. So we have to write down the equation of the horizontal asymptote to the graph of f. The way we do this is, since it's a function with a numerator and denominator, we look at the power of x value. So basically in both these cases, they both have an x value that's to the power of 1. So you take the coefficients of each of them and divide them by each other. So in this case, the horizontal asymptote will be 8 over c. And we know that c is negative 2, so our equation is y is equal to negative 4. The reason you can do the coefficients divided by each other is because when you do polynomial division, which is another way to find the asymptote, that will be the only value that does not contain x in the denominator. The other values will contain x in the denominator. So when you make x infinity, you make it as big as possible. Those values will become 0, since it's a big number divided by a very, very, very small number, which just gives you infinity. So that's the answer to part B. Part C is a little more interesting. So the line y equals k, where k is a real number, intersects the graph of f of x, well, the absolute value of f of x, at exactly 1 point to find the possible values of k. So we know that the absolute value function makes everything that's in it positive. So even if f of x in here was negative, the whole thing would still become positive and have the same value. So that's why there are two equations that we can construct. So k is equal to f of x and k is equal to negative f of x, and those will give us the two solutions. So firstly, k can equal 8x minus 5 over negative 2x plus 6. Well, that's the first equation. Or it can equal negative 8x minus 5 over negative 2x plus 6. So they're going to end up in the same way with the absolute value sign. So we just have to sort them out separately. So when you multiply, let's do it with the first equation. So this becomes negative 2kx plus 6k, which is equal to 8x minus 5. And if we collect like terms, we get However, we're not done just yet. Notice while we got a value k equals negative 4, that's not actually possible. Our values have to be positive, because when you graph these functions in the absolute value form, we get positive values only, because that's the point of the absolute value. So we're going to have to use our other solution instead. And there's still a solution out there that we haven't found, because it's asking for possible values. So let's first find the other one that's probably a little bit more obvious. So if we multiply the denominator, we get negative 2kx plus 6k is equal to negative 8x plus 5, which means that if we collect like terms, we get 2k minus 8x plus 5 minus 6k is equal to 0. So if we use the discriminant, again, since we have no a, this part is irrelevant, so it's just b squared is equal to 0. So our b squared is 2k minus 8 squared, which is supposed to be equal to 0. So 2k minus 8 is equal to 0, and k is equal to 4. And this value over here is a lot more plausible because it's actually in the positive region. Now, there is one more solution out there, and I don't think it's as obvious, but essentially it's the idea that this function over here will, sorry, not this function, the function over here, in its absolute value form, it means that the value can be negative or positive. However, think about what if it's 0? So there's only one value that can actually make f of x equals 0. Because if we write that out, let me just write it out here. It says 0 is equal to 8x minus 5 over negative 2x plus 6. The denominator cannot be 0, so 8x minus 5 is equal to 0. And of course, our value of x is 5 over 8. However, if you put 5 over 8 into the denominator, that does not give you 0. So that means we don't get an indeterminate value, we get an actual value of 0. So I think the other value that we have to consider here is k is equal to 0. So our two solutions are, let me write them down here, k is equal to 0 and k is equal to 4. And both of these are plausible because the absolute value function can make things equal 0, it just can't make them negative.